Hello and welcome to another case study of Net2Plan. Throughout this video, you will learn how to use the offline network design tool. This tool assists the user in the process of creating and planning offline network topology. With this tool, you can create complete topologies with nodes, links, routes, and protection segments. First of all, open Net2Plan, then click on Tools and Offline Network Design. You see, the window is divided into several panels. This panel, called Network Topology, contains a canvas that will be used to draw our topology. Here you will see all the nodes and links of the topology. Here in another panel we can see several warnings. We'll talk about this later. And on the right area you can see several tabs that contain statistical information about our network. We will talk also about this later. So before proceeding, using Net2Plan, we will try to recreate a 4-node topology with unidirectional and bidirectional link as seen in this picture. So to create this kind of topology in Net2Plan, just right-click anywhere on the canvas and select Add Node here. As you can see, this will add a node. At any time, you can click and drag, and this will navigate through your canvas. Also, you can click here to zoom in and zoom out. Also, this button will reset the zoom. We will add another node here. And at any moment, you can add links between two nodes just by clicking in one of them, dragging, and onto the other node. As you can see, this creates a unidirectional links between the nodes 0 and 1. If you want, you can also create a link in the other direction by clicking on 1, dragging onto 0. I will zoom to better see it. And as you can see, now we have a bidirectional link between 0 and 1. We will add the rest of the nodes. And also I will add the rest of the links. You can create directly bidirectional links by clicking on one of the nodes, dragging, and while maintaining pressed the letter Shift and releasing, you can create automatically bidirectional links. Another way to create bidirectional links is just right-clicking on the node, create bidirectional links between the node 2 and 3, and as you can see, this will also create bidirectional links. This can also be used to create unidirectional links. And lastly, the last link. Also, if you add a node and you want to remove it, just right-click on it and select Remove Node. This can also be achieved for removing links. You can see in this panel several warnings with our topology are displayed. For example, it says that all the links have 0 capacity. That's it because we have not defined any capacity for any of our links. No traffic demands are set, and no routing is defined for any element of the topology. This will be solved later. For now, we will see here several statistical information about topology. In the Edit Network Plan tab, under the Network subtab. As you can see here, you can see several statistical information. For example, the total number of nodes and the total number of links, the node out degree, and if all the links are bidirectional, and so on. As you can see, some of the information is empty because no routing and no demands are set yet. If we click on nodes, we can see several information about nodes. Here we can see that each node has an identification number, a name, we can change it at any time. Also, we can click here to show the name of each node and the coordinates of the node. This can be all the fields that are in color white can be manually modified. For example, if we want to modify the coordinate of the nodes so the topology is more symmetrical, this can be easily achieved just by double-clicking in each of the fields we want to modify and typing any value. For example, if you want the node 0 and 1 to be on the same y-axis, we just double click here. We click here again. And as we can see now, the nodes are in the same axis. We can do the same thing with the node 0 and 2 to be on the same x-axis. And we will just click here, type the new value, and at last we will change also the values of the node 3. And as we can see now, our topology is more symmetrical and identical to the one shown in the slide. So now that we have our topology, we can save it at any time just by clicking on the Save button. This one here. This will save the current state of the network into a file. That means it will save all the nodes, the links, and any routes or protection segments or demands that are defined. So we just click, give it a number, and it will save the file as a N2P file. This is the kind of file that Net2Plan uses to store topologies. Just click on Save, and the design has been saved successfully. As part of this case study, we will use one of the topologies that are included in Net2Plan as examples. At any time, you can load any topology just by clicking the Load button. Several physical topologies are included in Net2Plan as an example. Use at your convenience. In this case, we will use this one called example 5 nodes. This is a simple topology modeling 5 Spanish cities. As you can see here in the warnings panel, it says that traffic demand set is not defined. We'll also load a set of demands just by clicking the Load a traffic demand set. And as again, Net2Plan includes several traffic matrices that represents traffic demands included are samples. So we will click here and we will select this matrix that has a demand set for 5 nodes topologies. And as we can see now, the warning has disappeared because we have loaded a demand set. If you want more information about creating traffic matrices, please watch the video case study Traffic Matrix Design. Now that the new topology has been loaded, we will review all of the tabs under the Edit Network Plan tab. As we can see here, under the Network tab, we can see now that the new information has been displayed. For example, the total number of demands, the offered traffic, expressed in air lengths, the block traffic, and so on. As you can see, since no routing has been defined yet, here you can see on the warnings panel that routing is not defined, this section will remain empty. So, back on the Nodes tab, here we can see several information about the nodes, as I've said before. As you can see, since no routing is defined, there is no ingress and egress traffic between the nodes, and also no traversing or total traffic. Field here called shared risk groups will be explained later. And as you can see here, there are several attributes defined for these nodes. All of the tabs of the Edit Network Plan, that means the network, nodes, links, demands, routes, protection segment, and shared risk groups, can define users can define attributes in them. These attributes may be used, for example, by several algorithms to interact with our topology. In this case, 2 attributes have already been designed: the level and the population. To add or edit an attribute, just click on the line, do right click, and add or edit attribute. For example, we will change the population of the city, and we will name the attribute as the same name that it already has, and we will add any value. As you can see now, the attribute population has changed. You can also add edit an attribute, or view edit all the attributes, or even remove them. Under the Links tab, you can see several information about the links of our topology. Again, each link has an identification number. You will see that in Net2Plan, each element of a topology has an identification number. You can see also here under each link, if you click on it, you can see that now on the canvas is thrown in blue. And you can see, for example, the origin node and the destination node of this particular link, the capacity expressed in erlangs, the carrier traffic and reserve for protection segment. As no routes or protection segments are defined, this will remain as 0 for now. As you can see also the length in kilometers of the links, the number of routes that are traversing this link. Also, here you can see if this link is a bottleneck of this route. That means if this link has the highest utilization, and also if this link belongs to any SRGs. As I said, this will be explained later. As you can see, the capacity of each link is shown in white. That means you can change it just by double clicking and type in any value. If you want to change the capacity of all the links at the same time, just right click on it and click on set capacity value to all, for example 35 erlangs. This can be done also to the length of the links. I will move here so we can see this better. Now, under the demands tab, we can see also here that each demand has an identification number. Each demand is represented by the ingress node, the egress node, and the offer traffic of this demand. As you can see here, each line will paint in blue all the nodes of the ingress node on the canvas. As you can see, since no routes are defined, there is offer traffic, but there is not carrier traffic, and all the traffic is marked as lost. Here under this column, you can see if the traffic is bifurcated. That indicates whether the demand has more than one associated route. That means the traffic is carried through 2 or more routes. And as we can see, since there are no routes, well, this remains empty. Also, again, we can define attributes for each of the demands. Under the routes tab, you can see since no routing is defined, as shown here in the warning panel, this will remain empty for now. Here also, since no protection segment is defined, this will also remain empty. Proceeding, I will explain what is a protection segment. Protection segment may be defined as backup routes that will only carry traffic when the original route that is backing is down. For example, if you have a set of demands between the node 0 and 2, and the route is traversing only these links, and this link is down, we can have a protection segment traversing between the nodes 0, 3, and 2. Then, this reserved traffic will only be carrying information when this route is down. We can define protection segments for any of the routes or the network that we want, or even we can define a protection segment for each one of the routes. More about this will be explained later. And finally, the last tab is called Shared Risk Groups, or SRGs. As no shared risk groups are defined, this tab will remain empty. The SRG is a set of links and nodes that are assumed to share a potential cause of malfunction. Thus, when this malfunction occurs, all of the elements of an SRG fail simultaneously. For example, imagine that we have this topology here. We can define several shared risk groups, as seen in this picture. That means if these shared risk groups fail, all of the elements that belong to the shared risk group will fail simultaneously. That means if a malfunction occurs, both of these links in both directions will malfunction as well. Also, if the shared risk groups do malfunction, then only this link will be affected. And if the SRG3 fails, well, only this link will be affected. Now, back to Net2Plan. There are several models that you can use to define service groups. The first one is you can add SLGs manually. For example, right-clicking and add SLG. As you can see here, each SLG has an identification number. This column here, MTTF in hours, means the mean time to fail. That is the mean time when the malfunction will occur in this SLG. Also here you can see the mean time to repair in hours. That is the mean time that this malfunction will be repaired once it has occurred. This information will not be used here in the offline design tool, but it is very important for the resilience simulation tool. More information about the resilience simulation can be found under the video case study resilience simulation. Now that we have defined an SLG, we can add nodes or links to this particular SLG. For example, we just click, and to this SLG we will add the nodes 0 and 2. You can add any nodes separated by commas. As you can see, if you click, you can see that the nodes 0 and 2 now belong to the same SLG. Also, you can add links. For example, if you want to know the identification number of this link, just click on it. And as you can see, this is the link number 1. And this one is the number 7. Now, back to the service groups. We will add the number 1 and the number 7 to the SLG. And now you can see that the SLG number 0 will have the nodes 0 and 2 and those two links. And that will create one SLG for each node of the network. You can also add one SLG per unidirectional link that will add, well, as it says, one SLG for each unidirectional link of the network. As you can see here, one node per unidirectional bundle of links that will add on SLG for each for all the links of the from one node to the same node. All the links sharing the same direction will be added to this particular SLG. And also one SLG per directional bundle of links will add all the links between two nodes to an SLG, and it will create SLG for all the bundle of links of the network. Now that we have a topology with nodes, links, and set of demands, we will proceed to create and add several routes and protection segments for this topology. So on the tab called Algorithm Execution, we can execute several algorithms that can modify or even create new topologies. Since Net2Plan is modular and open source, users can create their own algorithms, load them in Net2Plan, and execute it on every topology that they want. If you want more information about creating algorithms for the offline network design tool, please refer to the video offline network design algorithms. So as you can see here on this panel, we can select several algorithms. Net2Plan has several algorithms included, as you can see here. You can visit net2plan.com to view the source code of each one of them. Now, here on the description, we have a description of each one of the algorithms that we click on them, and also we can see the input parameters of these algorithms. For this example, we will click and select the CFA shortest path fixed utilization. When we click on it, we can see the description of the algorithm that said that this algorithm will route the traffic according to the shortest path and then fix all the links capacities to match a given congestion figure. Here we have two parameters. As we can see, the first parameter, called CG, is the fixed links utilization. Expressed as a number between 0 and 1. We will select, for example, for 0.75, and the criteria to compute the shortest path. There are two criteria valid in this algorithm, hops or kilometers. We will leave it on hops. And once we have selected our parameters, we just click on execute. And as we can see here, the algorithm executed successfully. Well, just click on OK. And as you can see, the design is successfully completed. As you can see, the earlier warning that said that no routes were defined on the network has disappeared. So if we click again on Edit Network Plan and the Network subtab, we can see now that the routing has been defined. There are now 20 routes, as we can see, one route for each demand. It says that the traffic is not bifurcated, and you can see also several information. If we click now, for example, under the routes subtab, we can see now that several routes are defined and shown in blue in our topology. Each route again has an identification number and the identification number of the demand associated to that route. It has an ingress and egress node on the route, the demand offered traffic, and the carried traffic. You can also see here the sequence of nodes, the sequence of links, and the sequence of nodes of each route. For example, if we click here, we can see that this route has the sequence of links 10 and 0, and the sequence of nodes 3, 0, 1. You can see the total length of the routes, the bottleneck utilization. As you can see, since we have used a fixed utilization of 0.75, well, of the bottleneck utilization is the same for each route. Now, if we click, for example, on links, we can see that the capacity that we earlier set to 35 has now changed to accommodate the utilization to 0.75. As you can see, each links has now a carried traffic. Since we have not defined any protection segments, no traffic is reserved for the protection segments. And if we click on demands, we can see here that the offered traffic is now carried. And as you can see here, no traffic is lost. And you can see now the route that carries the traffic for each one of the demands. I will execute another algorithm, one that not also generates routes, but also protection segments for these routes. So we click again on algorithm execution, and this time we're going to select the algorithm FATS min congestion 11. This algorithm will try to create routes for each demand of the network, minimizing the congestion, and also it will try to create a protection segment with each one of these routes. So again, as you can see, we have here the description of the algorithm and the input parameters. This time we will not change any of these parameters. We will just click on execute, and as you can see, the algorithm has executed successfully. We see now on the warnings panel that some links are overcongested. That is, they are carrying more traffic than their link capacity. We will review this now. So we click on Edit Network Plan and on links. And as we can see now, under the column reserved for protection, we have now some numbers. That means that the link is carrying this traffic and has also an amount of bandwidth reserved for the protection segments. Since utilization is calculated adding these two numbers, we can see that the utilization of these links generates no congestion. So we can solve this easily by just changing the capacity of the links. We will do it now. Set capacity value to all, and for example, we will assign 45 air lengths to all links. And as you can see now, there is no overcongestion, and the warning panel has disappeared. If we go to routes, we can see again that it has generated routes for all the demands of the network. but the important thing is under the protection segment subtab, we can see that the protection segments are essentially backup routes. So each route has an identification number, an origin node, a destination node, and a reserve bandwidth for the route that is protecting. Again, we can see that it's drawn the path in blue on the canvas, and we can see here the number of routes and each one that is protecting. As we can see, the protection segments are protecting one route each one, and there is a protection segment for each one of the routes of the network. Again, we can see the sequence of things and the sequence of nodes. And that's it, how to generate easily using an algorithm some protection segments. Also, at any moment, you can also view several reports about topology. Again, since Net2Plan is modular and open source, you can generate and create your own reports, load them, and use it in Net2Plan. If you want more information about how to generate reports, please view the video case study reports. As you can see, Net2Plan includes several algorithms for generating reports included. As examples, for this case study, we will use this one called report topology. So we click on it, and we just click, as you can see here, a description of the report. This report shows basic information about the network plan, and you can see also that some reports may include input parameters. This one does not. And you can see, if you click on show, that it generates a complete report about the topology that we have here. As you can see, it's a complete report with quite the information about the topology. At any moment, you can click here on View in Navigator. Since the report is generated as a HTML file, it will be opened on your default browser. So you can then review some detailed information about your topology, like the capacity metrics, or the traffic metrics, and so on. And that's all for this case study. Thanks for watching, and please visit net2plan.com.